Hello and welcome everyone to our channel. So in this series, we're going to be dealing with the past questions on C and C++. Right, so in today's video, we're going to have some questions, or we have some questions already. And so we're going to treat these questions in this session. So let's go with the question. The first one says, what is a Boolean expression? Right, so what's a Boolean expression? So we're going to also define or explain what a Boolean expression is. And then the second one says using truth tables to determine whether the two Boolean expressions in each of the following are equivalent. So like use truth tables to determine whether the two Boolean expressions in each of the following are equivalent. So they give us Boolean expressions. So we are going to evaluate the two of them to see if they're equivalent. So for I, we have this group and then this group. Second one, we have this group and then this group. We have for I will have this group and then this group. Sorry, we have this group. So this is actually one group. The and is actually what's dividing them. So this group and then this group. Then we also have this group and then this group. So for the I, we have not into A and B, and then the second group is not A and not B. The second one is not A or B, and then the second of that particular group is A or not B. For the I will have it as A and B or not A and not B. Then the second group of I is not A or B, and then the other one is not A and A. So we're going to evaluate all of this to see if they are equivalent or not. And the third question is to write a C++ logical expression to represent each of the following conditions. The I is, we have to represent to show if either n is between 0 and 30 inclusive or equal to 35. The second one is to write a condition to show if n is between 0 and 40 but not even. The third one is to show if n is greater than 16 and n is an odd number. The fourth one is to show if n is a prime number but not even. So we are going to write all about this in this particular session. So without much further ado, let's just get into solving these particular problems. Okay, so the first one is to define what a Boolean expression is. So we are going to say question 1, question 1, a Boolean expression. A Boolean expression. A Boolean expression is a a Boolean expression is a logical statement that evaluates to either true or false, right? And so we can also say that the expressions involve the use of they involve the use of either relational either relational or logical operators, right? They actually involve logical or relational operators, and are used to they are used to control the flow of a program, such as in conditional statements, right? And so we can give examples of this. So we can give examples. So let's say we have 5 is greater than 3. So this is a Boolean expression because in this case we are going to have it as true, right? We can also have something like 4 is not equal to 0, which in this case is going to evaluate to true also. We can also have something like 5 is less than 1, which in this case is actually going to be false because 5 is not less than 1. You can also have something like 10 is actually not equal to 10, which is also false. We can also have something like true, and then you have the logical and false. So these are all logical expressions. True and false is going to evaluate to false. So that's actually about the Boolean expressions, right? And so the second one is to use truth tables to determine whether the two Boolean expressions in each of the following are equivalent. So we're going to solve them one after the other. What we're going to do now is that we're going to, for each of them, draw a truth table that will help us to better understand this. So let's go into doing that right now. So for the first one, we have it to be to solve for, this is 2i. So we're solving for a not a. So we want to solve for not a and b, and then the second one is not a and not b. So we are going to check for all conditions of a and b. So the way to check this is that if we're going to say these are equivalent, then for any value of a and b, if we plug those values into these equations or into these expressions, they should each of them give us the same result for each values of a and b, right? So but if they don't give us the same result for all values of a and b, then we're going to say that they are not equivalent. That's just how it is. So to do that, now let's draw a truth table. So just since we're working with the logical expressions, the only possible values that a and b can be is that either a can be true or a can be false, and then also either b can be true or either b can be false. So the so in this case now, since we're having a and b, we're going to have 4 possible conditions. That is probably when a is false and b is false. You can also have when b is a, let's say a here now, and then let's be b here, right? So we're going to have 4 possible conditions. So either a is false and then b is true. Then we're also going to actually have either when a is true and b is false, and then we're also going to have either when a is true and b is true. So we're going to test all these 4 conditions for this particular expression. So if using the conditions of a and b and plugging it here, we have the same output for not a and b, and then not a and not b. Sorry, this is actually inside of bracket, right? So that means that this not actually affects everything inside the bracket. So we are going to test that. So if they all give out the same output, then we're going to say that the both expressions are equivalent. So let's solve that right now. Okay, so let's go. So we're going to have the first one is going to have A, and then we're going to have B, right? And so now to help us better understand this, let's just do the inverse, because we're going to do an AND of the not A and the not B. So I would like to just do for not A also, and then also not B, so that I'm just going to AND these expressions and then look at what they're going to return. All right, so the next thing I'm going to do right now is to put it in bracket and say what is not A and B. Or let me even do it this way. Let me remove this not here. Let me remove the not, and first of all do for A and B before doing the not, so that we are going to understand what it is all about. So we have A and B, and then we're going to not A and B to know what is going to be. And then the last one is going to be for not A and not B. Okay, so like we just said, the four possible values is either when A is false and B is false. Then we can also have either when A is false and B is true, or when A is true and B is false, or when A is true and B is true. Okay, so not A means flipping the values of A. So in this case now, not A means when it is not false. So not false is actually equal to true. Second one is also not false as not false. So we're going to have here as true. And then here is not true. So not true is going to mean false. So what is not true is actually false. Also here too is not A, which is not true. We're going to have here as false. Similarly, here it's also flipping the value of B. So here is not false. We are going to have it as true. Here also not true is going to be false. Similarly, not false is going to be true, and similarly not true is going to be a false. Okay, so now A and B is ANDing the values of A and B. So when we have false and false, we are going to have it as false. Second one, false and true, is also going to be false. Similarly, here we have it as true and false, is going to be false. Here we have it as true and true, true and true is going to be true. Okay, sorry, let me put this bracket here. Okay, now the not of this is actually also flipping whatever value we've had here. So not of A and B is also, in this case, not of false is going to be true, not of false is true, not of false is true, and then not true is false. Okay, now here what we're going to do is ANDing the not A and not B. So not A and B is these two columns. So not true and true is going to be, sorry, not true and not true, just like ANDing this and this. So true and true is going to be true. The next one we have it as true and false. So here is true and false. So true and false is going to be false. In this case we have false and true. We are going to have it as false also. And then here also false and false is going to be false. Okay, now we have had our truth tables. So the two expressions we're going to work with is not A and not B, which is this column, and then not A and not B, which is this column. So now we have seen that when A is false and B is false, not into A and B is true and true. That means they are all the same here. Now when A is false and B is true, not A and B is true, while not A and not B is false. So they have cancelled. So we can see that in this case right now, when A is true and when B is false. Not A and B is true, while not A and not B is false. That is here, they've cancelled. So you can see here now, A is true and B is true. And we're having now not A and B is false, while not A and not B is false. That means they are okay here. So you can see in this case it's right now, at least they have a particular point where they are not the same. So in this case right now, you can see that when A is false and when B is true, and also when A is true and when B is false, they are not the same. So we can say that, or they don't give the same output. So because of these two conditions where plugging these two values did not give them the same output, you are going to say that they are not similar. So we are going to write here, say, since the expressions do not give the same output for all possible values of A and B, they are hence not similar, right? So they are not similar because they did not give us the same output for all possible values of A and B. Okay, so that is that. So let's go to the next question. We have it as 2ii. So 2ii is going to be here, 2ii. And so that one is for, let me copy it out again. Sorry. We have not A or B and A, not B. Okay. So we have it as not A or B, and then we also have A or not B. Okay, so in this case also, let's also draw the truth table. So we have A and we have B. So here we're going to also have, we're also having the not A and not B. So let's do not A. Let's also do for not B, right? And then let's do for not A or B, and then let's do for A or not B. Okay. Okay. So now we have it as A is going to be false. False. A is false here. B is true. A is true. B is going to be false. A is true. B is going to be true. So not A is going to be true. Not of us also is going to be true. Not of true is false. Not of true is false. Not B here is also flipping this. So not false is true. Not true is false. Sorry. Not false here is supposed to be true. So not false is true. Not true is false. Not false is true. And not true is false. Now, so not A or B, so means this column or this column. So this is true or false. So true or false is going to be true. Now true or true is also going to give us true. False or false is going to give us false. And then false or true or false is also going to give us true, right? So the second one is to do A or not B. So we are going to do this column or this column. So false or true is going to be true. False or false is going to be false. Then true or false, sorry, we're doing A or not B. So false or true is true, yes. False or false is false. And then true or true is true, and then true or false is false. Okay, so in this case we're also saying that for this same a and b values, they are the same. Here and here are the same. Here they are not. So we have seen at least one. Here they are also not, right? And here also they are also not the same value. Hold on please. What we have here is true or false. Here is supposed to be true actually. Yeah, because true we have here as true and we have here as false. So true or false is true. So they are both the same here, but at least we have two conditions where they are not the same. So we are going to also say the same thing. Similar, or they are not similar, anyhow I want to put it. And so that answers for 2ii. So let's go to the not the second, or sorry, the third one, which is 2ii. So we have here as 2ii. Let's go to see what it's like. So we have here as a and b, or not a and not b, and then we have not a or b. Okay, so here it's going to be, we have it as, so we have it as a and b, or not a and not b, and then we have it as not a or b. So a and b, or not a and not b. So let me just confirm again. A and b, or not a and not b, and then a and b. Okay, so that is it. So we're going to also draw the truth tables for this one. So we'll have here as a, we'll have here as b. Now we're having not a and not b here, so also let's also do for not a, let's also do for not b, and then we are going to do, so in this case now we have ORing a and b, so let's also do for a and b, which is this first one. Then we're also going to do for this, so that we are going to just OR the expression. So let's also do for not a and not b, right? So we're just gonna OR them, and then we are also going to have not a or b, right? Okay, no, let's do it this way. Let's just remove this. We are going to OR these two together. So we're going to have a and b, or not a and not b. So like after having these two expressions, we just OR them here, and then we're also going to have not a or b. Okay, so that is it. So let's get our possible values. A will be false, here will be false, a will be false, here is true, a is true, b is false, and a is true, b is true. So not of false is going to be true, not of false is true, not of true is false, not of true is false. Here not of false is true, not of true is false, not of false is true, not of true is false. Okay, so a and b is adding these two, so false and false is going to be false, false and true is going to be false, true and false is going to be false, and then true and true is going to be true. Not a and not b is adding these two, so true and true is going to be true, true and false is going to be false, false and true is going to be false, false and false is going to be false. So A and B, or not A and not B, is ORing these two together. So false and true. In this case, you can see this expression is this one is this one. So I just kind of did them together. So I'm just going to OR them together. So ORing this is going to just make it simpler for everyone. That's why I just did this particular column, so that it will be easy for us to get along with it, right? So in this case now, false or true is going to be true. False or false is going to be false. False or false is also false. And then true or false is going to be true. Sorry, yeah, true. In this case now we have not A or B. So we have here as not A or this one. So here we're having true or false is what? True. We have here also as not A or B. So true or true is true. We're also having here false or false is going to be false. We have here as false or true is going to be a true, right? So here we see they are the same for A, here also, but here they are not the same. You can see here they are the same, here they are not the same. So we have at least a condition where both of them are not the same. So we're going to say that they are not similar. So since B, they are not similar. So that is for the two I, right? So the next one is for IV, which is 2IV. I think I have that one offhand, which is just about not A and A, right? So that's about this. So in this case now, since we only have just a single expression or single data, the two possible values of this is just going to be that A is true or A is false. So we're going to draw for A. We're going to have it when A is true or when A is false. Okay. So in this case now we're having not A, right? And then we're also going to have not of not A. Do you get? So we'll just compare this and this. So when A is true, not true is going to be false. Now not false is going to be true. So not of not A is meaning nothing this one, like flipping this other one now. So not false is true and not true is false. So we can see when we have it as not A, here is true and here is also true, which is these two expressions. Then when not A is false, here is also false. So we see that they are having the same output for both values of A, or for any value of A. So we are going to say that since the expressions give the same output for all possible values of A, the expressions are said to be similar. Okay, so that solves for question number 2. So let's go to the last question in this particular session right now. Okay. So the third one is to write logical expressions to represent each of the following. Okay, let me just kind of snip this from here so that we're going to see it down. Let me snip this right now. Okay, so let me, so I can copy it down and we can see what we're doing. So let me come here and paste it. Okay, so write logical expression to represent each of the following. Either n is between 0 and 30 inclusive or equal to 35, or we say n is between 0 and 40 but not even, or we say n is not greater than 16 and n is an odd number, or we have that n is a prime number but not even. So the first one now, either n is between 0 and 30 inclusive or equal to 35. That means that n is a number that is within a range 0 to something around 30, and then n is also a number that is equal to 35. So how do we put this into a Boolean expression or a logical expression? The way to do it is that we are saying that n is between 0 and 30. That means that n is greater than 0, and then we're also saying that and n is less than 30, right? Okay, and then we're also saying that n is equal to 35, so we're going to put here as a bracket, and then we say and, sorry, we have an or here, or equal to 35. So let's remove this. Let's remove this. So or n is equal to 35. Now please note, they said that either n is between 0 and 30 inclusive. So when we say inclusive, that means it is not only greater than or less than the number. We are going to have that number is part of the range. So that means n is less than or equal, sorry, greater than or equal to 0, or n is less than or equal to 30. That means including 0 and 30. So that is for the first condition. So this is the logical expression that represents what we have here. Then the second one is that n is between 0 and 40 but not even. So the second one, n is between 0 and 40, is also similar to this same thing, but because we say that they are not inclusive, we're going to just have it that n is greater than 0 and n is less than 40. So it's not including the numbers, right? So we're not going to put an equal to sign here. Now we'll say that they are not even. It's not even. So even though n is between 0 and 40, we're going to exclude the even numbers that is inside of this expression. So that means n cannot be 2, n cannot be 4, n cannot be 6, or any even number that is between 0 and 40. So how do I going to put that is to say and n modulus 2, or sorry, how to represent the even numbers is to do something like this. So for even numbers, now dividing an even number will give us a remainder of 0, and the remainder operator is this modulo. So that means n modulus 2 is not equal to 0. So you can see that means n is between 0 and 40, and n modulus 2 is not equal to 0. That means for any value of n, that its modulo will be 2. For example, now 4, we are not going to have here to retain it. So for example, now if we have that n is 3, so we are going to say a 3 is between 0 and 40, and you can see 3 modulo 2 is not equal to 0. So that satisfies this condition. Okay, so the next one is that n is greater than 16 and n is an odd number. If you see between this number 2 and number 3, they're kind of similar, because when we say n is between 0 and 40 but not even, and here it's saying n is not greater than 16 and not an odd number. So when n is not an odd number, sorry, when n is an odd number, that means it is also not even. So we can also borrow this particular kind of expression we have here in our question I. So we have that n is greater than 16. So that means that n is greater than 16, right? We have that n is greater than 16 and n is having it to not be equal to 0 for the modulo. So n modulo 2 is not equal to 0. So this satisfies it. N is not greater than 16 and n is an odd number. Now, for this is I. Okay. Now, for the IV, you're going to have something very, very critical here now. They say n is a prime number, but not even. Now, there's no operator that is used to represent a prime number, except there's a function that is created already for us to identify this. So we are going to do some kind of assumption here, right? We are going to assume something. So we are going to say assuming that is prime. So like is prime is going to be a function. Assuming that is prime is a function for evaluating prime numbers. If it is a function that evaluates prime numbers, then the logical expression can be given by, so in this case now, so we say that this is prime now, which will give you as a function. It's like a function that is used to test if a number is prime or not, because there is no operator that does this in any programming language. So we're going to use a function for that. So we're going to say if that exists, then we're going to have that our expression is going to look like something like this. So is prime of n. So if n is prime, it's going to give us true. So is prime of n but not even, then we'll have it as is prime of n and but not even. That means it's also odd. So that means n modulo 2 is not equal to 0. So that is that about that. So that is that about these questions we have on the screen right now for this session. I hope that you understand everything about this video. If you also have other ones that you want me to help you solve, you can post it in the comment section. Please do help me subscribe to the channel, share this video to others, say your comments, say everything you want about in the comment section. I can't wait to see you again in our next video. But before that, do have a nice day. Thank you.